Now, you have, stay with me guys, you have your unit circle. And everybody draw a unit circle here. Draw a unit circle at the top of your paper. Unit circle because here's your XY axis in the middle. Sorry about that. My lines are off. And it goes out 1 unit, up 1 unit, down 1 unit. So all the quadrants contain either zeros or 1, the minimum values or the maximum values. Now, way back in Algebra 2 also, I describe it like this. I put a string around here. I start at my 0, and I rotate my string this way like this, and I cut it. And I take this string and I unravel it so that I start my string here and it goes like this. So I have my quadrants, 90, 180, 270, 360. We're in radians. Just kind of work along in radians with me. Now, I've got all my angles laid out. 0, 90, 180, 270, 360 on my x-axis, right? So I say x, y, cosine, sine. The sine is the y value. So at the 0 degrees, what's my sine? 0. At the 90 degrees, pi over 2, what's my sine? 1. At the 180 degrees, what's my sine? 0. At the pi over 3 pi over 2 at the 270, what's my sine? And back to 2 pi, full circle, what's my sine? 0. This is the pattern that we use for sine. Every time you make a sine curve, it has to pass through 4 quadrants. I don't care where those 4 quadrants are going to take place, but your sine curve to complete 1 full cycle has to pass through 4 quadrants. So the sine, 1 complete cycle, has to go through 4 quadrants. This gives us our minimums, our maximums, and our zeros. Okay, so now, all we have to do is follow that chart and graph. So at the 0, I am 0. At the pi over 2, I am 1. At the pi, I am 0. At the 3 pi over 2, I am negative 1. At the 2 pi, I am 0. And we make this a curve. Try not to, like I did, to make it a point. It's very hard to make a curve on this thing and as I'm trying to talk and turn. So if this is part of our sine curve. Now, your sine curve is continuous. It doesn't have a stop and a start place technically. Technically, we say our cycle, though, goes from 0 to 2 pi because we take this off of your unit circle. So technically, 1 cycle is from 0 to 2 pi. 1 full cycle, right? Now, your sine curve itself keeps on going and going. It's like a radio wave. If you play music, it's like your music waves. It's like a radio wave, like a seismic wave that they send out to the ocean floor, or a radio wave, or a music wave. They're all sine curves. So I go the opposite way. I have to keep on going with this. So look, come the opposite way to graph my negative. 0, negative 1, 0, 1, 0. And this will keep me going. Now, technically, I keep on going. I only can graph what you give me to graph in. This is my window for graphing. This is not my domain of my curve, though. My domain says you can go on and on and on and on forever, right? This curve keeps on going and going and going both directions, right? So my domain says all real numbers. Any angle you give me, I can find you a sign for. Whether it is in the 360 or in up to 720 or up to the next full circle, if I go backwards, I can find you a sign for any angle you give me. So this goes on and on. My range says, well, the highest and the lowest come from my quadrants. So 1 to negative 1. So negative 1 to 1. Right? Because I'm on my quadrants. The largest sign I can get is a 1. Remember, your 30 has a half. Your 60 has a radical 3 over 2.866. They're all between negative 1 and positive 1. So, okay, so good point. Where's 1 max?
1 max is at pi over 2.
Good. So, Monasia says this is a max. Pi over 2, 1. There's a max. Where's another max that you see, Gabe? Where do you see another max for my curve?
Negative 3 pi over 2.
Good. Negative 3 pi over 2, 1. That's another max. Okay. Jen, where do you see a min? Good. Negative pi over 2, negative 1. Okay. Oh, and where do you see another min? A minimum value. Lowest part of my curve. Here's 1. 3 pi over 2. Yep. 3 pi over 2. Negative 1. Aren't those my mins? Okay. Azure, where do you see a 0?
Pi.
Oh, pi. Perfect. Pi, 0. Alasia, where do you see another 0? Negative pi. Sandy, where do you see another 0? 2 pi. Oops, 2 pi, 0. Jeremiah, where do you see another one? 2 pi over 1, we got 2 pi. What else is 2 pi? Negative 2 pi, but where else?
0.
0. Don't forget the 0. Okay. 0 is a 0 degrees and a 0 radians at the same time. God bless you. So this is my basic sine curve. Now, it fits this format. For now, we're not going to do a shift right now. We're just going to keep it very simple. It fits this format. So the A stands for my amplitude. Amplitude measures the crest of my wave, or the dip of my wave, from the resting point. Some people call this a midline, because it's midway between, or a resting point. So it's like when your waves go up and down and then they rest. So from here to here, or from here to here, is my amplitude. It's always going to be the same, from the resting line, or the midline, if you will. Now, my amplitude is always measured in a positive value because it's the distance from here to here. Okay? So that's my amplitude. My B is my frequency. Now write this down. Frequency means how many complete cycles. How many complete cycles in 2 pi. This is really, really important. How many complete cycles in 2 pi? So if my frequency is 1, that means in 2 pi, I went around my unit circle 1 time, right? So if my frequency is 2, in 2 pi, I got to do the thing twice. So we're going to get to that in a second. Yes?
What's the second one say of the page 90?
1, 1. I just put 1s there right now. Okay, so now we've got one more thing to discuss. The period. The period says how long to complete one cycle. So how long did it take me to complete one full cycle on this graph? 2, 5. It took me from here, from the 0, here's my full cycle, to the 2 pi. My formula is 2 pi over b. In this case, b is 1. So therefore, it took me 2 pi to complete one full cycle. It's kind of like, it's the same thing if you think about your frequency right now, but that's because they're both 1. How long to complete one cycle? How long did it take to complete one cycle? Okay so far? Okay. All right, now, we're going to do the same thing with your cosine curve. Same thing. So we're going to draw your unit circle here. We're going to label your, but I can't reach up there. We're going to label your quadrants. Okay? And again, your cosine is your x value. So we're going to pull this out. For 0 radians or 0 degrees, what is my cosine? 1. For pi over 2, what is my cosine? 0. For pi, what is my cosine? -1. For 3 pi over 2, what is my cosine? 0. And for 2 pi, back to my original, 1. This is my pattern that I'm going to use whenever I make my cosine. I've got to go through 4 quadrants to make a complete cycle again. So my normal cycle says from 0 to 2 pi, 4 quadrants, and we're going to use 1, 0, -1, 0, 1. Now notice, it's the opposite of the sign, because look what happens. This is 1, 0. This reversed it, 0, 1. Isn't that 90 degrees difference? So if I actually took my cosine curve and I shifted it over 90 degrees, it would fit right on top of my sine curve. So we're going to start like this. Watch. At the 0, we're 1. At the pi over 2, the 90, we're 0. At the 180 pi, we're -1. At the 270, 3 pi over 2, we're 0. At the 2 pi, we're 1. So here's my curve. It makes a U. And it will keep on going. Now, I'm going to backwards this to go the other way here. I started at the 1. I went to the 0. I went to the -1. I went to the 0. I went to the +1. Okay, so here's my sine curve. Here's my sine curve. So if I took this dark black line and I moved 90 degrees over, wouldn't it coincide with that curve? Because aren't my quadrants 90 degrees apart and their opposites 0, 1 and 1, 0, right? So that makes sense. Again, this is my amplitude 1. This is my frequency 1 right now. Means I have amplitude of 1. There's my distance from the crest to the top. Okay. Frequency of 1. That means I have one complete curve, one complete cycle in 2 pi. My period says 2 pi over b. So 2 pi over 1. It takes me 2 pi to complete one cycle. What's the domain for my cosine curve? Just keep on going and going and going forever. Good. Negative infinity to infinity. I can use any angle you tell me to. What's my range? Where's my y's going from? Negative 1 to 1, inclusive. These are my max and my mins again. So again, if I ask for a max, there's a max. At 0, 1. At 0 degrees or 0 radians. There's a min. This is a min. At pi, negative 1. Here's a 0. At pi over 2, 0. So my goal is, by doing my 4 quadrants, I get my max, my mins, my zeros. Now, cosine of 30. Here's my 30-degree angle. Cosine is 1, radical 3, 2. Cosine will be radical 3 over 2, which is about 0.866, right? So cosine of 30 would be here. But there's my 0.866. Okay. Cosine of 60, 0.5. There's my 0.5. See it? Now, watch something else here. This is my quadrant 1. Isn't cosine positive in quadrant 1? Right? Because it uses the x-axis. From 90 to 180, I'm in quadrant 2. What values do I have down here? Negatives. Isn't my cosine negative in quadrant 2? In quadrant 3, here, isn't my cosine negative in quadrant 3? And in quadrant 4, isn't my cosine positive?
Yeah.
So doesn't that make sense with your unit circle? The graphing part of it's a lot easier. All you have to do is get a system down.
So are we never gonna go above 1?
Well, for our unit circle, no, but when we change the amplitude, yes. But we have a nice routine to change that. So questions so far? Okay. So let's take a look at, well, what happens when we change some of these things. So right now, we're going to change, let me put some color in here. We're going to change what part? Oh, orange. What's my amplitude going to be? 1. What's my frequency going to be? 2. Now, pick up your transformation sheet for me for a minute. Now, look down where it says horizontal. It says, when the absolute value of b is greater than 1, is 2 greater than 1? Yes, we have a horizontal shrink by a factor of 1 over b, which would be 1/2. Okay? I followed your transformation rules. After we graph it, we're going to look to see if that makes sense. What I wanted. So now, let's put our basic sine curve here for a second. In dotted lines, in like little shaded. We said we followed your pattern of your thing. It went 0, 1, 0, -1, 0. I want you to write this down. This is the pattern. This is going around your unit circle. Go back to your sine curve. Didn't we find that pattern? Okay. So your basic sine curve, just in dotted lines, went here, it went here, it went here, it went here, it went here. This was my basic sine curve. Okay? And again, it went the opposite way here. Good. My basic sine curve. Okay, my amplitude is 1. Now, it says I want you to do 2 of these guys. So my frequency says 2. And write this down. I want 2 complete curves into pi. That means if I go from 0 to 2 pi, I want to see 2 of those things, not 1. This is 1 complete curve from 0 to 2 pi. From 0 to 2 pi now, I want 2 of these curves. So listen to me in degrees. If it takes me 360 degrees to do 1 complete curve, how many degrees will it take me to do? It will take me 360 to do 2. How many of those added for 1 will it take me to do? I'm saying this wrong. My frequency is now 2. I need to put 2 curves in 360. How many will it take? How many degrees will it take to make 1 of those curves? 180. So you just said 360 divided by 2. Isn't this 2 pi divided by 2? Isn't this your period? So every pi, I have to make a curve. So in other words, I need to go block, block. I need to make 2 of them. But watch how we're going to do this. Make a line at pi. That's where we have to complete 1. How many quadrants do we pass through to make a unit circle? 4. So from here to here, I need to section this in 4 equal parts. Well, this is half, and then I'm going to section this in half. So I have 4 quadrants I'm going to pass through. So just watch for 1 second, and then we'll do it again together. I'm following this pattern on these tick marks. 0, 1, 0, -1, 0. Did I just make 1 cycle? So again, let's make your tick marks. By pi, we have to complete 1. Did we complete 1? Make 4 tick marks. Follow this pattern. 0, 1, 0, -1, 0. Now we're going to do it again. We said we needed 2 of these guys, right? So from here to here, I need 4 equal quadrants. The key here is 4 quadrants. Section it in half, and in half again. So now, 0, 1, 0, -1, 0. Do I have 2 now? Don't I have 2 of those complete loops things? Right? I have 2 in 2 pi. My period is pi. I didn't change my amplitude. So let's look at the shrink concept here. I did a horizontal shrink. I took my red sine curve and I did this. I compressed it. I shrunk it down. So when you shrink something down, you take a portion of it, right? Technically, we're looking at your period on this. Instead of 2 pi, we went to pi. So we shrunk it in half. We shrunk the period in half. That's what the shrink means. It has a little bit of a weird effect. Even though you have more cycles, your period shrunk. So we're looking at horizontally, taking that sine curve and saying, whoops, shrink you in so I can fit 1 here and I can fit another 1 here. Make sense? Now, can I do it to the negative side as well? Sure. Every pi, I'm going to make 4 quadrants. Just work yourself backwards. 0, -1, 0, +1, 0. It's almost like if I let myself go freehand, I would keep doing this and not stopping. But because we have to have some kind of a marking, this is the easiest way to do this. We're still sketching, but we need to make sure that it's falling where it's supposed to fall. Yes. Yes. If there's a security guard up. Are we good on this so far? Okay, for my blank faces? Okay, now, I line this up and I say 1 sine 1/2 x, a sine BX. So I also look at my transformations, and I notice that it says if B is between 0 and 1, that means B is a fraction, doesn't it? Which I have, a fraction. Then I have a horizontal stretch by a factor, and watch what it says, by a factor of 1 over B. Now, my B is 1/2. This means what to me? What does this mean to me? What does 1/2 for B mean?
Slope.
It's still absolute value. I want a half. A half of what? Half of my curve in 2 pi. Very good. I want a half of my cycle in 2 pi. So let me just think about this for a second. If I'm going to do a half of my curve in 2 pi, how much longer is it going to take me to complete this curve? 4 pi. Very good. And isn't the period 2 pi over b, which is 2 pi over 1/2. Oh, keep change flip. Flip this over to 2 over 1. Ah, so 4 pi, I should complete my full cycle. Now, let's just take a look at your sine curve. 0, 1, 0, -1, 0. So 0, 1, 0, -1, 0. Make this a dotted line. That's my original curve. Right? Now, half of my cycle says this. If my period is 4 pi, how many quadrants do I need to go through to make a complete cycle all the time? How many quadrants on my unit circle? 4. 4. Now watch up here. This is key. Right here. Take your period and divide it by 4. Every quadrant is now pi. Not pi over 2. And not pi over 4. Every quadrant is now pi. So I've got to be here, 0, at the pi, 1, at the 2 pi, 0, at the 3 pi, -1, and at the 4 pi, 0, if I came out this far. So let's label those. So here's my sine curve. From here to here, didn't I do half of my curve? From 0 to 2 pi?
Wait, you can do that again?
Sure. I have to go through 4 quadrants. Even though I'm going to do half of my curve in 2 pi and the other half in 4 pi, I walk through 4 quadrants. So if you wanted to, from here to here, you know you're doing half of your curve. But technically, every quadrant is pi units apart. So I start 0, then I go to pi, 1. I'm following my cycle. I come back down here, pi again, 0, to 3 pi, -1, to 4 pi, 0. So technically, this is my complete cycle. But from 0 to 2 pi, isn't that half of my cycle? Now, look back to up here. It said stretch it by a factor of 1 over b. Well, b is a half. So if I keep change flip, this gives me times 2 over 1. This gives me by a factor of 2. So didn't I take your sine curve and stretch this thing all the way out like this? Right? So when you stretch something, you have to multiply it by a larger number than 1, right? So doesn't that make sense by a factor of 2? I'm stretching by a factor of 2. Okay? So I have a horizontal stretch by a factor of 2. Did we change your domain on this? Nope. Did we change your range? Nope. We didn't change anything there. So does that make sense to you? Half of my cycle. Okay? I think there's one more we can try. Bypass that one for now. Go to this guy. This is a good one to do. Now, remember when we did these So we had a parabola, and then we did this. What did the 2 do? Brought it up 2. So that has the same effect to your cosine curve. This is where my amplitude is, not my amplitude, but my 1, negative 1 is going to change. But you know what? The same thing here. I didn't really like looking at it like this. So let's move this to the end. My amplitude is still 1. My period is still 1. Anybody remember the pattern for cosine? 1, 0, negative 1, 0, 1. Good, good. Now, my amplitude didn't change. But each one of these points, I have to walk up 2. So watch what we're going to do. We're going to add 2 to everybody. I got to walk this guy up 2 units. Okay? So before we add those, can I just put your basic cosine curve here for a second? So your basic cosine curve said 1, 0, negative 1, 0, 1. So just a little dotted line. Okay? Now, we're adding 2. So my first one should start at 3. My second one should start at 2. Negative 1 and 2 gives me 1, 2, 3. This is the pattern I am now going to follow. Okay? Unfortunately, do you have room to bring yours up higher? Okay, so let's do this. All right. Can I erase this? Probably not. All right, I'm just going to move it out of my way for now. Okay. Can you change yours to go to 3? Is that a problem? I'm sorry. I didn't anticipate this. I'm sorry. So here's your basic cosine curve right here. We're just going to shrink it down a little bit so that we have room. There's your basic one. So now, follow those greens. I start at 3 every 90 degrees because my period is 2 pi because my frequency is 1. I start at 3 here. Then at pi over 2, I go to 2. Then at pi, I go to 1. Then at 3 pi over 2, I go to 2. Then at 2 pi, I go back to 3. Here's my cosine curve. Didn't I take this from here? Isn't this my resting line here, my midline? Didn't I go from here? Isn't this my midline now? Do you see my shift up too? So did it change my domain? No. So my domain is still the same. Now watch how we work with the range. The range originally is negative 1 to 1. But essentially I moved everybody up 2. So I just add 2. So my new range is from 1 to 3. And don't those numbers over there in my pattern show me from 1 to 3? Yeah? Okay. One more thing. Let's do one more thing. We can fit this in. Back up to this guy. We have a phase shift. Now, right now my B is 1. So it looks like this. Sine bx plus c. Remember when we did this? What did that cause that to do inside the parentheses? Excuse me, yes. Horizontal movement to the right. So this is also going to be a horizontal movement to the right. Now, the thing is, right now B is 1. So our formula is this. C over B. This is C. Pi over 2. Guys, hang in with me. This is 1. So instead of starting at the 0, we're going to start at the pi over 2. Okay? Now, normally we said we go from 0 to 2 pi. So we're going to take this guy, set it equal to 0, and take it to set it equal to 2 pi. I want to see where should my complete cycle be? I add pi over 2, so I'm going to start at pi over 2. I add pi over 2, so I'm going to have to change this denominator to a 2. So this will give me 4 pi over 2. So this gives me 5 pi over 2. It's okay, just hang in there for a second. So I'm starting at pi over 2. Did my amplitude change?
No.
Okay, so hang with me. The sign is 0, 1, 0, negative 1, 0. So start at pi over 2. 0, every 90 degrees. Pi, 1, 0, negative 1, whoop. Instead of 2 pi, this is 5 pi over 2. 0. There's my first complete cycle. So I gotta fill in the rest of this. All I gotta do is go backwards. Every pi over 2, negative 1, 0, 1, 0, negative 1. So my original sine curve started over here and went like this. See my shift? Look, isn't it 90 degrees to the right? Didn't I take that and I shift it 90 degrees to the right? That's just a basic phase shift. If you have trouble with that part in your homework, if you see these in your homework, don't panic, we'll do those together tomorrow, but the rest of that homework you should be able to do in the packet. No, I gave you it separate, right?